Hi everyone, and welcome to Maths Revision with Jov. Another A-level problem today, and it says that ABC is a triangle, angle A is 60 degrees, and the lengths of AB and AC are 4 plus 8 centimetres and 4 minus 8 centimetres respectively. The question is asking, show that the side BC is such that BC squared equals 16 plus 3h squared, and for small h, small values of h, show that BC is approximately 4 plus lambda h squared plus mu h to the 4 for some lambda and mu. So it's asking us to find these values, lambda and mu here. Now you're probably thinking, oh my god, that is such a long, difficult question. How am I ever going to be able to approach that? Well, luckily for you, I'm here to show you how. The first thing you want to go ahead and do is you want to make sense of the question. So we're going to look at each part of the question and go through it. The first part is ABC is a triangle. It's probably best to draw that triangle. Let's draw it like this. We've got A here, for example, B here, and C here. Angle A is 60 degrees, as it says in the question. And the lengths of AB and AC are 4, so AB is 4 plus h centimetres, so write 4 plus h, and AC is 4 minus h. And it's asking us to find the side BC, so for now let's just call that something like P. Call that P for now, just to make it shorter to write. And yes, asking us to find the length PC. We're given one of the angles, we're given the two adjacent sides to it, and we're being asked to find the opposite side to it, which means we're going to have to use one of the trigonometric laws. Now it looks like we're going to have to use the cosine law, which, if you remember, says that a squared is equal to b squared plus c squared minus 2bc times the cosine of A, where this little a is the opposite side to this big A angle here, and B and C are the other sides. Let's go ahead and substitute our numbers in. So this A squared over here, this corresponds to the P over here, so we've got P squared, and that's equal to, well, B and C are just the adjacent sides here, so we get 4 plus h squared minus h, hopefully you can see that, and then multiplied by the cosine of 60 degrees. Now we can probably go ahead and simplify this quite a lot. We get p squared down here. P squared is equal to, well, we're going to expand these brackets. I think that's probably the best place to start. So 4 plus h squared is 16 plus 4 times h times 2, because there's two of them, is 8h, and then h squared on the end, plus another 16, because we've got 4 minus h squared now, minus 8h, and then plus h squared. And then over here we've got to be a little bit careful here, so we can probably start by saying that, okay, cos 60, well, if you know your cosines off by heart, or if you can probably work it out as well, but this is actually equal to a half. The cosine of 60 is a half. So we get minus 2 times this double bracket times a half. So actually this half and this 2 will cancel out. So we're literally just left with this bracket over here. And so I'm going to have minus, and big bracket for now, 4 plus h times 4 minus h. Well, that's just a difference of squares. So we get 16 minus h squared. We've now got some simplification to do. We've got 16 over here, another 16, that's 32, and then we've got a minus 16 in here, so we're back to 16. We've got an 8h here, and an 8h here, a minus 8h here, so they cancel out, so that's all the h terms. And now we've just got an h squared, another h squared, and then a minus of a minus h squared, so that's 3 altogether, because the minuses cancel out, so we get a 1, 2, 3, plus 3h squared. And hey look, it looks like we solved it. So we found BC squared, which is just this side, we've called it P for now, but this is just the same as what we have in the question. BC squared is 16 plus 3h squared. Before we dive into the second part of the question, it's important that we first look at what happens when we take square roots of something in a bracket. This will help us because we're actually going to be taking the square root of both sides over here, and we're looking for some kind of expansion where we get higher powers of h. So in order to do this, we can write, for example, 1 plus n times x to the half, where n is some constant, is going to be roughly equal to 1. And if you notice, I'm going to be doing a Taylor expansion. This is a nice simple way of doing Taylor expansions for just polynomials raised to some powers. So plus, we actually multiply by the power, and then by this second term here, nx. We then add another term, and this time we have to do a half, because this power over here, multiply that by that power minus 1, which is minus a half, then divide by the factorial of 2. This is stuff that you may have been taught before. I can go over this in another video if you like. And then multiply that by nx all squared. And it looks like this is as far as we're going to need to go, because we're only going to be looking at 3 terms. So let's dive into the actual question now. Okay, so we worked out before that p squared is equal to 16 plus 3h squared. We can actually go ahead and take square roots of both sides. We get p is equal to 16 plus 3h squared all to the power of a half. This happens to be equal to, well, we can take the 16 out here, and we want to reduce it to 1 somehow. We want to have a 1 in here. So we actually get that this is 16 lots of 1 plus 3 over 16 h squared, because we've got a 16 divided out here and then multiplied here, so we get this 3. And this is all to the power of a half, okay? We can actually go and take square roots of both individually, because when you raise everything to a power, you can just raise the individual things to the same power. So we get 4, because square root of 16 is 4, times 1 plus 3 over 16 h squared to the power of a half. Now is the fun bit. So p is going to be equal to 4 lots of this thing expanded like I showed you before. So you get 1 plus the half, because it's the power, multiplied by 3 over 16 h squared, and then we can add the half again, multiplied by minus a half, divided by 2 factorial, which happens to be 2 in this case, multiplied by 3 over 16 h squared all squared. Now we've got the gnarly simplification coming up, so I can go ahead and quickly do that just to save you a bit of time. So once everything is expanded and simplified, we actually get that p is equal to 4 plus, this simplifies to 3/8 h squared, and then this simplifies to minus 9 over 512 times h to the 4. There are further terms, but the question says for small h, show that this is true. So for small h, so we can neglect any higher terms, because if we keep raising this sum to more terms, we just get h to the 6th and h to the 8th, and then they're going to get really, really small really quickly. So this here is our final answer. So lambda we found to be 3/8, and mu we found to be minus 9 over 512. And I hope that helps.